Hello to viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're gonna talk about DIY power meter, meaning this puppy that I have built. So let's talk about this. Well, reality is it's not something that it's one of those things that I do not need it, it's a desire. Well, reality is at this point in time it's a need. Well, simply because we consume a boatload of power. For example, most of you would be in a position where if you are paying electric bill, you'll be like, dude, why the heck my electricity bill is so goddamn high? So that's the reality is, and it's throughout the world, and we have to pay for it. And even if you are thinking about stealing it, it's a very short-term solution, because if more people start to steal electricity, government runs out of money and power cut, the end, cut. So you have to understand, we have to pay for it, and we are paying a boatload of money for it. And you have to understand, we are blind to application, basically appliance level power consumption. What does that mean? That simply means if you ask any Tom, Dick and Harry, hey, what is your house's power consumption, they can tell you, because, well, they see the power bill. They're like, yeah, we are consuming, let's say, 100 units of electricity or whatever have you. We know about those sort of things. And in terms of kilowatt rating, we have a line which has this kilowatt of capacity. Everything is awesome. But here's the how much energy your appliances consume. We have no idea, because many appliances that are dumb appliances and very straightforward, those have fixed draw. For example, your water heater, it has a fixed draw, meaning I'm going to consume 5 kilowatt. Okay, that's a fixed draw. Then the how much energy is consuming, that's directly proportional how long it stays on. So if you are very conscious about energy, you'll be like, okay, I'm going to turn it on in the morning, and I'm going to turn it off after, let's say, I leave for office, and only next morning I'm going to do it. So you have a fixed power consumption. You're like, I know how much this is. But what about dynamic loads? For example, computers, which is a very big power consumption nowadays. Computers, mobile phones, these sort of things, they consume a lot of power, and we are blind to it, meaning you have no exact idea. It's like you may have a computer that has power supply of like 600 watt power supply, but maybe it's running on 200 watts. And you may have a power supply that's only 400 watt, but it's almost like 350 watts all the time. See, that's why we are blind to it, specifically when it comes to dynamic power equipments. So we have to know that. And then there is a consequence of things having phantom draw. For example, generally it's recommended you should not have your AV equipment, meaning your TV, your subwoofers, basically, or everything. Those things should be turned off by one main switch, meaning you just like turn off. You should never do remote turn off, simply because even if I turn these sort of thing on or off, they have a phantom draw, and that's how they can be turned on once you press something in the remote. Inherently means it's consuming power. So these sort of phantom draws could be very significant. For example, I have a main inverter that is feeding a smaller UPS. That UPS is providing power to my basically computers. Now the reason why I'm doing like this, simply because inverter, while it does have GG amount of backup capacity, it does not have voltage regulation, meaning whatever voltage comes in, when in my scenario it's very dirty, I could get as high as like 300 volts. It's gonna feed 300 volts to my power supply. My power supply is gonna go poof. So I have to send that to UPS. UPS is acting as a very good stabilizer. I can't use normal stabilizer simply because switching delay, it will restart my system. So everything is working fine, but I thought, like, because this UPS is connected to a main inverter, meaning from a UPS point of view, it's running on constant power, it should not have any power draw, because the battery would be charged to a full extent. Maybe a little bit of power draw, but it should be fixed. Once I actually connected this puppy to this meter, I realized this puppy was consuming 50 watts continuously for no reason. Like, there was no power draw, it was still consuming 50 watts of power. I was like, wow. Again, I do have two UPS, one for this TV, one for computer, but it was like, wow. That was a big whoa, a serious shock moment. Like, because before this, I did not knew and did not even think about that, and did not turn off my UPS at the night. Whereas, and I mean turn off from the power cable, because when you turn off UPS from the main button that it has, like UPS big button, it did not do anything. I did not knew about that. That's the whole thing. That's why we are blind to application level, basically appliance level power consumption. We have to pay for it, and we have no idea about phantom draws. Many things have phantom draws. So this is why I'm specifying this equipment as a need, not a luxury, a need. Now, AC, you have to understand some component aspect of AC. Is basically measuring AC is easier and difficult at the same time. For example, you don't only need to measure voltage. You can buy a meter for like this. You don't only need to measure current using clamp meter, utilizing this puppy. You also have to multiply it by time, and that alone makes it very difficult, because you can't just sit there and plot out a graph on a spreadsheet where it's like, okay, at 10 minutes, 12 minutes, 13 minutes, 14 minutes. Yeah, it's not going to be very accurate, and not to mention very tedious. So that multiplication by times inherently means you have to buy something that is built for that, meaning kilowatt hour kind of rating. It has to be built for that. Now, thankfully, there are two ways of measuring AC current. For example, even if you have like a cheap meter like this, you will notice that it has a system where it's like says something like 10 amps or 20 amps if you are talking about some expensive meter, and it has a shunt cable, meaning a cable that is directly acting as a bridge. Now, Benefit, it measures very accurately. Side effect, it's a bridge, meaning if you send, let's say it's a 10 amp equipment, you're sending it, but for some reason it started to draw 12 amps or 13 amps, yeah, this puppy is going to catch on fire, or basically the fuse will blow out if you're lucky. But you get that point. That means inherently this equipment is limited. Now that's the one good thing about AC equipment, because it has magnetic field, alternating magnetic field. Using coils, my example, this puppy, coils, you can read the current, meaning you just have to send the conductor through it like this, and you don't have to worry about it. You can measure it. Like this puppy, the small ones, they are limited to 10 amps. This puppy, 1200 amps, meaning don't worry about it. Meaning this, I can measure power draw of a big building, as long as the voltage is like, not too dangerous to be around. For example, let's say 400 600 volt, this puppy can clamp it on, read it properly, no issue. But again, there is a limitation to that. Like, do not try to do this on, like, substation. It's gonna go poof with you probably. So that's the thing that you have to understand. You have to generally use coils. Shunts are more accurate, but they have a power limitation. Coils are far more flexible. Basically, this coil puppy, this can easily read up to 100 amps of power draw. Now there are bigger systems that can read to 500 or 600 amps, but 100 amps for home appliance is more than good enough. 100 amp, multiply that by 200, that's boatload of energy. One appliance should not consume that kind of energy, home appliance. So coils can be used for current measurement, and small power draw over time adds up. That's the thing that you have to learn about it. It's like, that's why kilowatt hour ratings are so important. You turn off, for example, I have a basically fiber internet modem. Now that stays on most of the time, as all of you would do that. But do you know how much power that is adding up over a month? Because you pay a monthly. Do you know how much that is consuming? You may think, oh, it's a small one, but what if it has dirty power factor, which mine has? Like, I was shocked when I was like testing it out. It has dirty power factor, and I was like, wow, it was costing me a lot of money. So for that reason, you have to have something that multiplies it with time. And small power draws are the biggest issue, where it's like you don't think about them, but they slowly pile up and easily eat away your basically your monthly savings. So that's why you need something that can show all that. Now thankfully all these motor does that, but problem is they only do it for house level equipment. And even though in India we are starting to implement much more advanced meters than this puppy, even they have serial ports, but those are not supposed to be accessed by individual, meaning those are only there for, well, not actually for any use, it's just there. It's like even the basically people who come and collect the reading, they are not connecting a port there. They're like, it's just there. It's like a lost potential, so to say. So AC is bit complicated, especially when you have to multiply by time. Now power factor is the most dangerous aspect. When I connected my meter, well, this puppy, to UPS system, I realized the power factor was very fluctuating, because it has an active power factor correction system. At low power it was giving me dirty power, meaning it was like 0.5, as not 0.5, I think it reached 0.7 at dirty power factor when my UPS was only idling, quote unquote. But when it had like high power drop, then it started to go to almost 9, 8.5. It's easily staying like at this point it's 8.7, so it can easily sustain that kind of power load. And this is the hidden power draw of AC system. This is one of the most complicated things. That's why measuring AC is so complicated, because if you have ever noticed, everything says I'm in kilowatt. Like this TV claim have a rating of 300 watts, which I really don't think it can consume 300 watts. I have measured it. This puppy barely consumes 50-60 watts. It's like, did LG just recycle the box? It does not even have speakers that are like 300 watt RMS. It's like, why? But you get the point. Like everything has a power rating in terms of kilowatt. But why the heck everything that makes power has a rating in VA? Meaning if you buy a UPS or inverter like this puppy I have, it's like 2.5 kVA. Why the heck it's not kilowatt? And you buy a solar inverter, many of you may be thinking about getting into solar power, you will also find that all the inverters are rating in kVA. They are not in kilowatt hour, they are in kVA. In terms of generator, same thing. In terms of transformer, same thing. No transformer ever made has like a rating of 50 kilowatts. They're like 50 kVA. Or in terms of huge transformer, it would be like 200 MVA. It will never be kilowatt hour or megawatt hour. It's like, it's always in terms of power factor. So you have to understand, that's why power factor is not something you can ignore. And that's why buying a meter that has like dumb meter which has like voltage, amps and watt, you may think that's all you need, but you also need goddamn power factor. Now I would have wished that this 6-in-1 meter would have kicked out that 50 hertz, which is useless for me, and replaced it with VA rating. But well, we win some, we lose some, and that's the whole point. Big power, basically bad power factor. For example, my fiber router, it has power factor of 0.5, meaning the adapter that is utilizing, it's a multi-volt adapter, is really cheap quality, which means even though it's showing me, let's say for example, when I connect the meter, it shows me 6 watt, it has power factor of 0.5, meaning I'm paying around 9 VA. My inverter is paying 9 VA of energy not 6 VA, because of the bad power factor. It's one of those things that you do not pay attention to, but it does consume power from your basically everything. That's why you have to understand. And we are very lucky, especially in most places of the world, we have to pay only for kilowatt. But the moment you start to go into commercial or industrial section, you have to pay for kVA and kVR. Now you're like, why? Well, government has to lay down the cable for it, and that cables have to be rated for kVA, and transformer have to be rated for kVA, because that's why many times transformer starts to blow up if the industry do not have power factor correction. Now again, you may be like, I will pay for it, but here's the deal, still wasted energy. Wasted energy simply means transformer is heating up. You don't want transformer to boil, especially in India, when outdoor temperature can easily be 52 degrees Celsius. I have reached as high as 55 degrees Celsius. So you get that point. Like you really don't want a bad power factor, and that's why like this is a hidden thing that we do not care about, but it's over time. Like imagine it this way, like how many small equipments that you have and which have dirty power factor, and you add it up to, like, let's say large building. You'll be like, dude, this whole building has dirty power factor, because people are not paying attention and they don't have equipment to measure it. So that's why power factor is one of those things that are hidden enemy. We must pay attention to it for sake of everything. Now, why I'm talking about this DIY option? Well, if you are familiar with this, what we call kilowatt meter, or like, micro power monitoring system, a lot of people have complained about like these puppy melting, simply because many of them are built very cheaply, and the plug wise, specifically plug problem is like some of countries in the world have different plug standards, but they are not different enough. Meaning, if you are clever with your metal bending, you can create a plug that sort of works for almost all of them. Meaning, this plug can work in Philippines, also work in India. You may think, okay, that's awesome. Well, not really, because that inherently means this puppy is not suited for any country. At low power draw, that's not an issue, but the moment you start to consume even its rated power output, meaning it has claim rating of 10 amps maximum, you start to draw 10 amp AC at 200 volts, yeah, most of them will start melting, simply because that plug connection is not absolute. It's like jack of all, master of none. So a lot of people have issues like melting, especially if you want to measure something high current draw, for example your air conditioning unit, water heater, like huge things. Yeah, this puppy will like, yeah, I really can't do that, I'm not well suited for that. In those sort of scenario, using this sort of meter that I have built is far more desirable. Now there is another aspect of it. If you type like 6-in-1, you get to see everything in one glance. You do not see just water, you see voltage, you see amps, you see power factor, all that in one glance, which is very critical. For example, if you have dealing with a dirty equipment, you can just see the power factor is bad. If you are dealing with let's say too much current draw, you can just see that amp draw is higher than it should be. If you're dealing with a scenario, for example, my UPS started to spin up the fan, and I did not get, like, why heck, it's cold here, then why the heck the fans were spinning? My UPS is like, shh. It's like, why? Then I realized, because apparently there is a time between, like, summer and winter, where you have so cold that nobody turns on their fan. And it's not cold enough where somebody turns on their heater. So that point, you have very serious drop in power demand. However, power supply is more or less working at the same capacity of summer, so you have voltage rise. And voltage, again, this should not happen, but it is happening. Voltage in my area was reaching 260 volt, which is supposed to be at 220. It was reaching 260 and 270, and that's why, like, because my UPS was stepping down the voltage, the transformer started to heat up, and it was running its fan to cool it down. It did not make sense to me. It's like, dude, it's winter, why the heck you are running fan to cool your stuff? Because of the high voltage. And that's why you need to see all these factors in one go. It's like, look, study everything, go home. And when you are talking about kilowatt meter, best one can only show you two factors. Like, they will have two lines. Most of them only have one line. Some expensive one have two lines. This puppy is like, dude, I can show you 4 data points that you need to know: voltage, amps, watt, and power factor. Now again, this hertz rating is 100% useless, simply because it's like, either it's gonna be 50 or it's gonna be 60, and you're like, what if it's changing? Well, you have bigger issues to deal with. If that number ever changes, again, it might change, especially if you can notice that power draws, you will have like 49.9, but don't worry about it. Like, if that changes, you have much bigger issues. So that's why I really wish if they had removed the hertz and put basically VA rating, but that's all. And power rating is the biggest benefit of using this design, meaning you can rate it however you want. I have built this puppy for 6 amp power draw, which is significant, as in, like, I can easily power like a big power heaters, but not for very long. This is like, this will be pushing it, and you never want to push your electrical equipment. You should always want to be comfortable. It's like, bro, relax. So this is good enough for my power supply, computer, and all that. I used to think my power computer used to draw a lot of power, but in reality it barely draws 200, and that's why, like, when I turn on this TV, power draw is still very low. And then I realized like this was not consuming as much power as I thought. Other things are consuming. That's why phantom power. I started to hunt down phantom power equipment. Now, if you are thinking about like, let's say in India, you want to like, hey, I want to measure a water heater or a basically big equipment, you can build a bigger variant. This is 6 amp variant. You can build a what we classify as 16 amp variant, or you can go even bigger than that. That's the amazing aspect of it. That's why I'm talking about DIY solutions rather than a kilowatt meter. You get to see far more details instantly. Now there is one advantage on this sort of kilowatt meter. Some of them have a good functionality where you can program unit cost, meaning it will only show me like 8 kilowatt hour, 10 kilowatt hour. Now this puppy can have like a multiplication factor. It's like 10 kilowatt hour multiplied by what is your unit cost. Using that, this puppy can show you the total bill that you're gonna get. That may be desirable, may not be, simply because in many places you have multiple tariff layers. For example, if you are consuming less than 100 kilowatt hours, you'll be like, okay, this is the price. If you start to go above that, the price changes. So in those sort of scenarios, this will not be as useful as you will think. Now, just seeing kilowatt hour, that's good enough. You can write it down and multiply it, and you're supposed to do that only like, a month, so to say. So that's not that big of a deal. But the fact that I can see the voltage, which allowed me to diagnose that power voltage was too high. That's why my UPSs were running their fan at full power factor, which allows me to figure out like what dirty equipments I have, and amp draw, which helps me understand like how big the cable should be that is running this equipment. And in terms of like 3-core wire that you have to run, you can buy a normal one. This is like a 1.5 square one. Or if you want to worry about like those big things one, you can have single cables that are huge, or you can buy cables that I basically used for my giant extension. Now these things are 2.5 square basically this puppy at 220 volts can power almost everything, or a small home basically. So this is what you will use if you want to test very thick equipments. So that's why I'm talking about DIY equipments. You can make it to whatever power standards you want. You get to see a lot more useful data in one glance. And the reset button, generally all it does is reset this kilowatt hour rating. Now there are many options also, meaning what I'm showing you, this is not the only option you can do. This is something that I did and I learned a lot from it. That's why I'm sharing this video. But you can go with DIN mounted option. For example, if you have a circuit breaker, big circuit breaker, you can buy things that are built for that. And I really like the design of that. It has like 2 voltage, basically neutral and live wire. And then you can send the main cable, basically main house cable, or that's feeding this box through this tube. Now this tube has no connection, like there is no electrical, it's just a current transformer. Somebody just figured out, wouldn't it be nice if we put the current transformer inside the box? So you have this whole unit completely flush with the equipment, and that's super awesome, especially if you want panel mounted equipment and you can literally look at the power draw of a whole building. That's awesome. And then you have smaller units also, like this unit. In terms of like this size, it's really good, but in terms of depth, it's like kind of tall. That's why it's not very flush. But you can find the some equipments that are a bit more cheap, basically flush, and you can go even pro level. Now be mindful, pro levels are a bit more expensive. Like this sort of equipment is like $3,000. The what I'm building is 2,000 rupees. This can go as high as 6,000. Now what's the benefit on that? A, those are 3-phase equipment. B, they have serial communication, meaning if you know how to deal with serial, you know how to decode protocols and deal with it, collect data with that, you can have this and read the power through, let's say, Raspberry Pi if you want to do that. So there are many options of this sort of power consumption rating, and it's far more like control is onto your hands, and you can do this. It's not something that is like, oh, super complicated, or you have to buy a boatload of things. This is something you can build, and you can build it to standard that you need. If you're only dealing with, let's say, TV, AV equipment, those are not consuming boatload of power unless you have like super high power root mean square kind of speakers, which are like 60 watts or 100 watts or 500 watts. Yeah, then you need to build something huge. But even those, generally, like how many of you have like speaker system that is like 500 root mean square? But you get the point. There's a lot of option. You can do amazing thing, and you can be far more grateful with that, simply because you will know, okay, what is consuming the power. Okay, do I have a specific equipment that is very dirty? You will figure out what to do with that. Either sometimes because it's just worth it to replace that equipment if you have bad equipment, especially if you are in a commercial sector and you do not even know that you are paying for kVA rather than kilowatt. You're like, yeah, fix the power factor. So there are many options, and it is one of those things that like you can invest a very little amount of money, learn something. It's a weekend project at best, and have something amazing to figure out, troubleshoot a lot of problems, save your money, save environment, everybody wins. So this was my presentation on my DIY power meter situation. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment, or 3 times, or ask, press it 5 times to show YouTube disappointment. But you can leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you are free, and as always, thanks for watching.